Good afternoon. It is May 25th, 2018. It's a special week for me because it's the 24th passing anniversary of my father. My father being a mathematician. We are here in Norway for a special edition of Fjord-tastic 5 with the University of California at Berkeley, professor of mathematics, Dr. Edward Frenkel, best-selling author of Love and Math also. And I'd like to talk to you, Dr. Frenkel, about the concept of fractals. Can you please let me know something about it, because that's a little bit of mystery. I learned something about it regarding when you're trying to determine how coastal regions are formed.
Right.
And so can you tell us a little bit more about fractals?
Fractals are very fashionable these days because, for instance, you find a lot of, we call fractal art. Sometimes interesting patterns.
Okay.
Sometimes you see in art galleries and so on.
Right.
But actually, the mathematical term fractal was first coined by the French mathematician Benoit Mandelbrot, and in the mid-1970s. And so it's actually kind of caught on, so there's a lot of research in this area. So what this is fractals describe geometric shapes, sort of contours such as the shorelines, like the ones we observe here in the fjords in Norway, which have this property which mathematicians call self-similarity. What it means is that the contour is sort of zigzagging, but it's zigzagging in a kind of unusual way, where when you zoom in, you might expect to discover the shoreline, the contour kind of flatten, become more like a straight line, but in fact it doesn't. And the closer you get, the more sort of little zigzagging you find.
The more the details of the zigzag you see.
The more the details emerge,
right,
the more zigzagging you discover. And then
kind of like a lot of things in life. The closer we get to it, you see the little details, you see the little veins, and you see the little trees.
And it's also interesting that, in fact, if you juxtapose the pictures at different scales, for instance, you can look from the satellite at the shoreline of a fjord, you see a particular. By the way, this kind of patterns you can also see in many other places. For instance, seashells or
broccoli.
Even broccoli, yeah, this kind of funny shapes, right? And so, if you juxtapose the patterns, you'll see that they're actually very similar. So, like, there is some kind of a genetic code of that fjord is built at many different scales.
Which kind of makes me think about the fact that in life we have broader horizons. We can look at things on a large scale, and we may not see the details, but as you get closer and closer and tighter, those things emerge. And that's how fractals are important, because it helps us remind us that the closer we tune into things, the more we find out about the things that we could not see before.
Yes, so it's not about flattening, but discovering more mystery.
All right.
Or like the more the wind is blowing, so you can see the fractal patterns of my hairstyle as well.
Well, thank you very much for describing this mathematical concept to our audience. We're thrilled to be here in Norway for the special edition, and I'd like to thank Dr. Frenkel for explaining it to us. Please join us next time on another edition somewhere in the world. Thank you very much, Dr. Frenkel. Appreciate it.
My pleasure.
Thank you very much.